So imagine walking into this perfectly silent, totally empty room, and you're holding a drumstick and you strike a crash cymbal just exactly once.
Just that single loud crash.
Right, just one crash. And then you ask yourself, did time just pass?
I mean, standard physics would say obviously yes.
Exactly, like an event occurred.
Right.
Right, state A transitioned to state B, so therefore time moved forward. But we have this fascinating stack of theoretical notes today.
Oh yeah, really mind-bending stuff.
Yeah, totally. And the mission of this deep dive today is to completely rewire how you understand time. Because these notes argue that with that symbol crash, you didn't just experience time, you actually just created noise.
Right, which is a wild concept to wrap your head around.
It really is. So welcome to the deep dive. We are looking at a radical new theoretical framework called RAF, which stands for the Relational Algebraic Framework. Specifically, we're focusing on a concept they title time as the memory of repeatable closure.
And, I think it's important to set the tone here. You absolutely do not need a PhD in quantum physics to grasp this.
Oh, thank goodness.
Right. You really just need to be willing to rethink what happens when things change. Because the premise driving this whole RAF framework is that change alone, just random change, is not enough to establish time.
Which is counterintuitive, right? Because we always hear time is just change.
Exactly. But they're saying a single isolated event, or even like a chaotic string of random events, it lacks the underlying architecture. You need a specific structure to generate what we actually perceive as a flowing timeline.
Okay, let's unpack this, because the notes make this really bold claim. They say time is not a fundamental dimension of the universe. It's not this, like, invisible river that we're all just floating in.
Yeah, that river analogy is so deeply ingrained in us.
It is. But RAF argues time is an emergent property. And to get that property, to go from just random noise to a measurable tempo, you fundamentally require three essential ingredients.
And those three are a stable closure, a repeatable update, and memory of the prior state. We should probably define those terms carefully because they really form the bedrock of this entire model.
Yeah, definitely. So start with that first one. What exactly do they mean by a stable closure?
So a stable closure basically refers to a system that establishes a boundary. It has an identity. I mean, it remains recognizably itself across state changes.
Like it doesn't just instantly dissolve into chaos.
Exactly. It holds together. And then the second ingredient is the repeatable update. This is the cycle or the operation that the system undergoes. The system acts, but it eventually returns to a state that is structurally comparable to where it started.
Okay, going back to my symbol analogy then. A single crash in an empty room, that's an event, but it's not a tempo.
Right. It's just a spike in noise.
But if I hit that symbol every 4 seconds, steadily bam, 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 now I have a beat. Now it repeats.
Yes. Now you have rhythm, which introduces the mathematical core of these notes, actually. They use this recurrence function, which they write out as R sub k of t.
And what is that equation actually doing?
Well, it's evaluating the structural similarity, the isomorphism, they call it, between a system's current state and its past state. So k represents the closure, the system itself, and t is the trace, or the memory, of the previous state.
Okay, so this function is calculating how well the system maps back onto its own memory.
Precisely. When that R function yields a high value, it means the system has achieved a highly repeatable rhythm. The current state heavily resembles the past state.
And if the value is 0?
If it's 0 or, close to 0, you just have pure chaos or pure propagation. There's no return, no cycle.
Just a symbol crash fading out forever.
Exactly.
Yeah.
Therefore, in this RAF model, proper time is defined strictly as countable recurrence inside persistent closure. Time is quite literally the rhythmic pulse of a system, continuously comparing its current self to its remembered self.
Okay, wait. If a system has to create its own internal rhythm to generate time, that feels like a massive shift in how we understand measurement itself.
Oh, it completely upends it.
Because, I mean, if you look at your own watch right now, the basic assumption is that it's passively measuring this universal river of time, right?
Yeah.
A river that flows equally everywhere. Are these notes saying our clocks are basically lying to us?
Well, they're not lying, but they are doing something fundamentally different than what we thought. Under the RAF definition, a clock isn't measuring an external river at all. The clock is actually creating the rhythm.
Creating it. So the clock is the source of the time.
Yes. A clock is just the physical manifestation of a stable rhythmic closure. Think about a grandfather clock's pendulum.
Or like the vibration of a quartz crystal in a wristwatch.
Exactly. Or even the atomic transitions of cesium in those massive atomic clocks. These are all just physical systems engineered by us to maximize that R function value.
They're built to be perfect loops.
Right, they cycle repeatedly with almost zero environmental interference. We don't use them to measure some invisible dimension. We just use their highly reliable internal rhythms as a baseline.
A baseline to compare against other stuff.
Exactly, to measure against other, less coherent changes happening in our environment.
But wait, if every single clock, or really every system, is essentially generating its own local time through its own recurrence, doesn't that imply that time is completely subjective? Like there is no universal now.
Well, yeah. But remember, Einstein's theory of relativity already proved that to us over a century ago.
Right, right. Two observers moving at different speeds will completely disagree on when events happen.
Exactly. What the RAF framework is doing here isn't contradicting relativity. It's actually providing the underlying mechanical reason for why relativity works in the first place.
Oh, that's fascinating.
Yeah, they use this progression in the text. They call it the ladder of reality. And it shows how the universe basically builds up to this subjective time.
Okay, let's climb that ladder. Where does it start?
It starts at the absolute bottom with pure uncertainty, just static.
Okay.
Out of that pure uncertainty, you eventually get a distinction, a fundamental difference between two states. From distinction, you develop a relation.
So things start connecting.
Right. And when those relations stabilize and actually form a boundary, you finally achieve closure.
The system gets an identity.
Exactly. But it's only when that closure learns to update itself in a repeatable cycle that you get rhythm. And time is simply the counting of that rhythm.
Wow. So time is basically an absolute latecomer to the whole architecture of reality.
It really is. The universe is functioning on relations and closures long, long before any cohesive rhythm emerges that we could even label as time.
But to climb that ladder, to actually transition from just a single update to a rhythm, requires that third ingredient we mentioned earlier, memory.
Yes, you absolutely cannot have that recurrence function without the T, the trace.
Right, because if a system doesn't retain a physical imprint of its prior state, it literally has nothing to compare its current state against.
Can't say, oh, I have returned to my starting position, because the starting position is just gone.
It's been overwritten. And what blew my mind in the notes is that they treat memory not as this like psychological phenomenon. It's not just a byproduct of having a biological brain.
What's fascinating here is that they define memory as a physical primitive. It's baked into the physics. Memory is simply the persistent trace of a prior closure.
The universe literally has to have a mechanism for state saving at a structural level.
Exactly.
I was thinking about this like a digital flipbook animation, like when you're rendering a 3D video game environment.
Oh, that's a great analogy.
Right, because if the graphics card doesn't hold the data of the previous frame in its video RAM, it can't calculate the vector difference to render the next frame of motion.
It needs that anchor.
Exactly. Without physical memory storage holding that prior state, motion, and therefore the illusion of time passing in the game, is literally impossible to compute. You need the trace map to render the update.
And that maps so perfectly onto what the text calls the RAF triad of reality: space, time, and memory.
They aren't separate things, are they?
Not at all. They are intimately linked. Space is simply the rendered map of stable relations, how things connect to each other right now. Time is the rendered rhythm of those stable updates, how those relations cycle.
And memory is the stable trace map.
Right. The structural footprint left behind by whatever was just there. Space cannot logically update into a new configuration without the trace map anchoring the geometry.
Okay, here's where it gets really interesting. Because if we take this new definition, that time is countable recurrence against a memory trace, we can suddenly solve some of the biggest mysteries in standard physics.
Oh, absolutely. Clears up so many paradoxes.
Let's start with the speed of light, because I was always taught, light doesn't experience time because photons are massless. And when you hit the speed of light, the equations of relativity basically reach infinity, so time dilates to a complete stop.
That's the standard textbook answer, yeah.
But are these notes saying standard physics is wrong about that?
Not wrong, just incomplete. RAF bypasses that relativistic math, the whole infinity problem, and just looks at the actual structure of the photon itself. In this framework, masslessness is just an emergent property. It's like a macro description.
Okay, so what's the structural reason a photon doesn't experience time?
It possesses zero internal recurrence. None. The photon is pure propagation.
Oh. It is the symbol crash, traveling forever through the void.
Yes, it never ever cycles back on itself. Because there's no self-returning pattern, its recurrence value is basically zero. It establishes no internal rhythm, retains no structural memory of a prior state.
And therefore, it has no internal clock?
Exactly. And without an internal clock, there is no proper time.
That is incredibly elegant. And we can apply that exact same structural logic to gravity, right? Because general relativity models gravity as this warping of space-time.
The bowling ball and a trampoline analogy.
Right. Massive objects create a depression in the fabric of the universe, and time literally stretches out and slows down the deeper into that gravity well you go.
Yeah.
But this RAF framework,
Yeah.
it just discards the idea of a fabric entirely.
If we connect this to the bigger picture, bending a geometric fabric is a really useful macroscopic metaphor, but it totally fails to explain the quantum mechanics of the interaction.
So what replaces the bending fabric?
RAF replaces it with this concept called local closure load.
Which fundamentally redefines what mass is actually doing to the space around it.
Exactly. Mass represents a highly dense knot of stable relations. So imagine you introduce a rhythmic system, say a highly precise atomic clock, into the vicinity of a massive object, like the Earth.
Okay, I have my clock near Earth.
You are plunging that system into a much denser relational web.
The environment becomes thicker with data, essentially.
Right. The physical conditions required for the clock to execute its internal update have suddenly changed. The clock has to process and negotiate a much heavier load of relational ties just to complete a single cycle.
Oh, I see. It's like trying to execute a really complex computational task on a laptop that is suddenly bogged down by 100 background applications running all at once.
Yes, perfect analogy.
Or swinging a pendulum in a vacuum versus trying to swing that exact same pendulum underwater.
Exactly. The pendulum itself hasn't changed. The mechanics of the swing are totally identical.
But the relational friction, the actual water molecules it has to push out of the way, forces the cycle to take longer.
And that is exactly what time dilation is near massive bodies. The system's cycle rate drops because the environmental update conditions are just far more computationally demanding.
So the rhythm slows down. Time itself isn't a substance getting stretched out like taffy.
No, not at all. The physical counting mechanism of this system is just struggling to maintain its tempo under a really heavy relational load.
That reframing completely bridges the gap between the macro scale of general relativity and the micro scale of quantum mechanics. Gravity isn't some mysterious force acting on a dimension, it's just a measure of relational density affecting how fast a local closure can cycle.
It's a beautiful way to unify things.
But what really grounds this theory for me is that it doesn't just stay out there in space with atomic clocks and black holes. The biological implications in these notes are arguably even more profound for you listening right now.
Oh, entirely. Because if time is fundamentally defined by rhythm and memory, then biological organisms like us are essentially highly complex, nested matrices of time generation.
We are just walking rhythm comparison engines.
The human brain, especially.
Right. The brain tracks an immense hierarchy of closures all at once. You've got cellular metabolic cycles, the rhythm of your heartbeat, respiratory loops,
The firing frequencies of neural oscillations.
massive circadian cycles dictating when you sleep and wake. Our perception of time is absolutely not a passive experience of some river flowing past us.
We aren't just sitting on the riverbank watching it go by.
No! Our brains are actively synthesizing all these overlapping rhythms. We're constantly evaluating that recurrence function of our internal states against the trace memories of the immediate past.
Which is brilliant because it provides a mechanical explanation for how our perception of time can distort so violently.
Yeah.
Particularly in psychological phenomena like flow states.
Yes.
Mhm.
When an athlete describes the game slowing down, or, a programmer looks up from their keyboard and realizes 5 hours have passed in what felt like 20 minutes.
Right. So in a flow state, your internal predictive models, your rhythms of anticipation, they align almost perfectly with the external patterns you're interacting with.
Your internal and external rhythms lock together.
Exactly. The friction between your internal closures and the environmental data drops effectively to zero.
The relational load lightens.
Exactly. Because your actions and predictions are structurally synchronized with the environment, your brain stops needing to constantly evaluate the trace map against unpredictable external noise.
You're not fighting the environment anymore.
No, you're merged with it.
Yeah.
And because the recurrent structure stabilizes to such a high degree, the subjective counting mechanism alters. The rhythm changes. So the time you literally feel and experience changes.
That's incredible. But there is a destructive side to biological recurrence too, which leads us to how this framework redefines getting older. aging.
Yeah, this is where it hits close to home.
We conventionally view aging as the collateral damage of passing time, right? Time flows forward, and as it washes over us, it degrades our cells, wears down our telomeres, causes our systems to fail.
The RAF framework completely inverts that causality, completely flips it.
Wait, really? So time passing doesn't cause aging?
No, you do not age because time passes. The passing of time is the perceptual symptom of your biological rhythms losing their coherence. Aging is literally defined here as the accumulated loss of clean, rhythmic closure.
So instead of a river washing us away, the mechanics of aging in this model look a lot more like making a photocopy of a photocopy.
That's exactly it. When a biological system is young and healthy, its internal cycles, DNA replication, cellular division, protein folding, they all have a very high recurrence value.
The update perfectly matches the trace memory. The photocopy is crisp and clear.
But the universe is incredibly noisy. You have environmental radiation, chemical stress, relational friction. All of this introduces tiny microscopic errors into the update.
So the trace memory starts to degrade.
Right, that R function fails to perfectly map the new state back onto the original closure.
And the next time the cell divides, it's copying from a slightly degraded trace. The rhythm becomes noisier. It's like an old car engine where the timing belt stretches and the pistons start misfiring.
Yes, the boundaries of the closure become less defined, and the accumulation of all this structural noise is exactly what we call aging.
Which explains so much about how time feels as we get older. We perceive time as passing more rapidly or feeling heavier precisely because the internal mechanisms generating our baseline tempo are struggling so hard to maintain their rhythm.
The biological clock isn't just a fun metaphor anymore. The degradation of cellular recurrence fundamentally alters your organism's relationship to time.
It's all connected.
It really is. It unifies the abstract algebraic topology of the universe directly with the physical reality of your cell's aging. Whether it's a photon failing to cycle, an atomic clock bogged down by Earth's gravity, or a human cell failing to replicate its trace memory, the underlying mechanism is mathematically identical.
So what does this all mean? If we step back and look at the whole picture, the entire universe is governed by the ability or the inability to maintain a rhythm and remember a prior state.
That's the core of it.
Time is not a flowing dimension. Time is the memory of repeatable closure. It is the footprint of a universe trying to maintain its structure against the absolute noise of uncertainty.
It really forces us to view existence not as a journey through pre-existing corridor, but as this active, continuous rendering process.
Yeah.
Without rhythm, there is only noise. And without memory, the rhythm is impossible.
That interconnectedness is just what makes this whole framework so compelling. But I have to say, it also leaves us with a rather haunting implication regarding the ultimate fate of the cosmos itself.
Oh, you're talking about the far future scenario.
Yeah, because physicists widely theorize that the cosmos is heading toward a state of heat death, right? Trillions and trillions of years from now, the expansion of the universe is going to tear apart all galactic structures.
The stars will all burn out.
Right. Black holes will slowly evaporate via Hawking radiation, and eventually all matter will completely decay, leaving absolutely nothing but a uniform, freezing soup of background radiation just scattered across an infinitely expanding void.
A state of maximum entropy.
Exactly.
Right.
Now, under standard physics, time would technically continue forever in that void, stretching on into an infinite, empty future, even with nothing happening.
Right. The dimension remains.
But if we apply the RAF framework, if time strictly requires the memory of a repeating pattern, what happens when the universe can no longer support stable closures?
When everything is gone.
Yeah. If there are no atoms left to cycle, no systems left to maintain a trace memory, and absolutely no rhythm left anywhere in the infinite dark, does time itself cease to exist? If the universe completely forgets its own song, does the tempo finally stop?
That is a profound way to look at it. Without closure, there is no time.
It really makes you appreciate the rhythms we have right now, so leave that question lingering the next time you hear a clock tick. We want to thank you for joining us on this deep dive today and encourage you to keep exploring the rhythms around you.
Thanks for listening.
Until next time.